Yes. Today let me just repeat a few seconds. We are studying the indefinite integrals today, where we are taking the integral here without a definite intervals. So in general, the indefinite integral is to find the antiderivative of the function f, which the derivative of f will give us the integrand here. That is indefinite integral. For example, we need to compute this indefinite integral of x squared. Yes, we can wait. I'm sorry for about the issue with the Zoom meeting. Yeah. And welcome to class, Lexi and Carrington. And here, in order to compute the indefinite integral of x squared, we need to find the most general antiderivative of this, which is x cubed divided by 3 plus a constant, right? We can check our result by taking the first derivative of this function. If it is exactly the same as the integrand, then our result is good. The key things is this. The indefinite integral gives us a function, right? Be careful. Or it is a family of functions, because each value of the constant c here will give us a function, right? So, however, the definite integral, for example, integral from 0 to 1 of x squared dx, as you remember, this will be the inner antiderivative of this guy. Evaluate from 0 to 1. And what do we have here?
I can't schedule reminders in the past. When do you want to be reminded?
Sorry.
I can't schedule.
My phone, I'm sorry. And here, what is it? What do we have from here?
Would it be 1 to the third divided by 3 minus 0 to the third divided by 3?
Perfect. And here, 1 to the third give us 1, and denominator is 3. So finally, it is 1/3, right? Very good. So here, with a definite integral, it will give us a number, right? So it is the big difference of definite and indefinite. This result gives us a number, but this one gives us a function. So we should be very careful. Thank you. Who was that?
Carrington.
Carrington. Thank you, Carrington. So, and in the notes, it is written here. So take a look at this. As a reminder, right? The definite integral gives us a number, while indefinite integral gives us a functions or a family of functions. Okay. And here they just remind us the fundamental theorem of calculus, right? Okay. Now, this is a table of formulas. antiderivative of a given function. The first formula here, if c is a constant, then we take integral of a c times f would be c times integral of f of x, or indefinite integral of a number k, it would be kx plus c, right? You can always double check it by taking the derivative of the right-hand side. So our job is to study all these things and memorize them. In the test, you are allowed to make a note yourself and use this formula. And remember, this is very important. Okay. But there is one convention. That is, we adopt the convention that when a formula for a general indefinite integral is given, it is valid only on an interval. So that is convention. For example, if we want to compute indefinite integral of 1 over x squared dx, right? It would be negative 1 over x plus a number c, where c is a constant. Okay. Look at this, the antiderivative of the function 1 over x squared is negative 1 over x plus a number c, right? In general, the antiderivative would be negative 1 over x plus a number c1 if x is positive, and negative plus a number c2 when x is negative. That is the general forms. We need to consider two cases when x is positive or negative. But if we take the indefinite integral convention that, okay, this is valid on an interval, okay? That's it. Now, let us take a look at this example. Find the general indefinite integral of this one, integral of x tan x to the fourth minus 2 secant square x dx. Okay. So look at the table of the notes that I gave you before, of these notes. What is antiderivative of x to the fourth?
X to the fifth.
Perfect. Antiderivative of x to the fourth is x to the fifth divided by 5. You did it so fast, Daniel. Thank you. So in order to find this indefinite integral, we need to find the antiderivative of each of them, each of the sum here, right? Each of the difference. And which function that when we take the derivative give us secant square? Look at the table I gave you and tell me what it is. Thank you, Lexi. 10x plus c, very good. Antiderivative of secant square is the tan function, right? And remember, we are computing the indefinite integral. Therefore, remember to add a number c. We can simplify it further. It will be 2x to the 5 minus 2 tan x plus a number c, right? Okay, that's it. There's nothing new. Okay, are we good? Please say something.
Good.
Thank you. Now let us do another example. We'll compute the indefinite integral of cosine theta divided by sine square theta d theta. This is a trig function, right? So what should we do? Look at the table. What do you have? What is the most related formula that we can use?
It's tangent, sine, cosecant.
Very good. Because we don't see anything similar to this, let us try to make it the way we are familiar with. So we separate this guy, the fraction here, into two terms. So here we have secant square, right? Secant square is secant sine, sine square, I'm sorry, I mean sine square. Sine theta times sine theta, d theta.
I meant cotangent, my bad.
Yeah, but we do slowly, but I know what I mean. Thank you, Daniel. So this fraction, if we separate it into 1 over secant, then what is the other quotient here? This is a fraction, right? And they're the product of 1 and cosine divided by sine times sine. So we can separate them into two quote fraction. The first one is 1 divided by sine here, and the second one should be?
Cosine.
Yeah, cosine theta over sine theta. So the logic here is we're trying to make it more familiar for us so that we can do something, right? What is 1 over sine theta? Sine theta is secant theta, right? Cosecant. 1 over cosine is secant, yeah. And how about cosine over sine?
Secant theta.
No, I don't think so. Secant theta is 1 over cosine.
That's cotangent.
Thank you. Okay, and now go back to the table of formulas. Which one should we use? Cosecant times cotangent. Are you looking at the table of indefinite integrals? Look at that and tell me what the antiderivative of this term is. Thank you, Lexi. It is negative cosecant x. Very good. And remember, we are computing the the indefinite integral. We must add a number c, which is a constant, right? does it. So it's not very different, right? So there are many applications that we can use. And one specific example is the following. Here, from the fundamental theorem of calculus to a definite integral of a function capital F here would be the difference of f at b minus f at a. If the volume of water is a function depending on t, then we can compute the volume change of the reservoir, which is this guy, okay? Integral of v prime of t dt from t2 to t1, okay? Or if v is a position function, then we can compute the distance from the time t1 to t2 here, okay? Actually, here there's a typo. This should be t1 to t2, okay? And here, sometimes we need to compute the total distance travel, if it traveled in the positive direction or in the negative direction. That would be the integral of an absolute value function here of vt dt. You can imagine it as a integral of this function. If vt is the graph here, then integral from t1 to t2 will be the sum of these areas, right?
Yeah.
Then, I'm sorry.
Yeah.
Do you have it?
So the distance, the displacement of the particle would be a1 minus a2 plus a3, and the total distance would be a1 plus a2 plus a3.
Yeah, we consider all the positive value of these, yes, for the total distance. Absolute value of v here.
Okay, I get it.
Yeah, very good. Thank you, Daniel. Now, let us consider this example. If a particle moving along a line and the velocity is given as t squared minus t minus 6 here, the meters per second. What we need to do is to find the displacement of the particle during the period from t is equal to 1 to 4. And in the second one, we need to compute the distance traveled during this period. Okay. Now, let us do it together. Here is a summary, so it's very brief. But you can see a hint here. We just applied the formula, right? In order to compute the displacement, we compute the integral of the function vt from 1 to 4, right? And we're given that vt is t squared minus t minus 6. dt, okay? So this is the sum and difference. So the integral of this, in order to find this, we need to find all the antiderivative of each of them, right? And what are they in this case? Do which one by one. What is the antiderivative of t squared?
T to the third over 3.
Thank you. Is it Faith?
Oh, yes.
Thank you. And negative t here.
T squared over 2.
Thank you. And the number 6 here?
And T.
Yeah, very good. Thank you so much. Here you see that the degree, the power, and the denominator cancel each other, right? If we take the derivative. And here we are computing the definite integral. So remember that we evaluate the value when t is equal to 1 to t is equal to 4, right? And this is not difficult, so try our best to make it right. Don't be confused. Oh, from 1 to 4 here. The upper limit first, it would be 4 to the 3 here divided by 3, right? We evaluate all of them. That is the first value, right? Subtract the value of this function at the time t is equal to 1, and what do we have here? So we need to evaluate the value of this function at 1, right? And what do we have?
One cubed over 3.
Thank you. Minus 1 squared over 2, right? Minus 6 times 1. And let us simplify it. Okay. That is one way to evaluate this, right? Let us simplify it first. 4 cubed, 4, 4, 16. Is it 64? Yeah, 64 over 3. Minus 16 over 2, right? Minus 24. All of them subtract. Yeah, let us remove the parentheses here. Subtract, this is 1/3. Remember, there's a negative sign here. And what is it next?
Just 1/2.
Yes, 1/2 and
Plus 6.
thank you. here we go. Then finally, you will find that, okay, this result is -9/2. Okay. Do you have any question about this? Thank you. So let's go. Let us move on to another part, part B, when we want to compute the distance. Here, there's a hint already. Let us continue doing it from here. So here, in this formula, in order to compute the distance, we need to use this formula. But remember, absolute value of x, what is it when x is positive? Can you tell me? Absolute value of x?
It's going to be x for all x greater than 0 and -x for all x less than 0.
Perfect. Right. Very good, Daniel. So you see that here we are facing the same thing, absolute value of the function, right? Let us simplify it, make it easier by breaking into two parts. The positive part, then we will get rid of the absolute sign here, right? And the negative part, if we know where it is positive and where it is negative. So in order to study where the function v is positive or negative, what should we do? The easiest way is to make a table to study the sign of this, right? And there are two solutions of this one. There's -2 and 3, right? Let us make a table of t when t in general. T should not be 0, but let us continue doing it in the general case. And we need to care from the interval of 1 to 4, okay? 1 to 4 is here. And this function has two solutions. The first one is -2, right? The second one is 3. Let us break it into two small functions, t plus 2 and t minus 3, okay? At t, the function t plus 2, what do we have here? Is 0. For any t smaller than this guy, what is the sign of the function t in general? Is it positive or negative?
Negative.
Very good. Here's positive, right? The same story at t minus 3, the solution is 3, so this function will be 0 here. And whatever smaller, t smaller than 3, it will be?
Negative.
Yes, Is it Vikram?
Yeah.
Thank you. So we know the table, right? And V is the product of t plus 2 and t minus 3. Therefore, it would be 0 at 0 here. But in fact, we care about this part only, from 1 to 4. But anyway, we do it in general case. It would be positive, product of negative times negative, it would be negative, and this one would be negative. This one would be positive, right? And here it would be positive. Okay, so this function is positive from 3 to 4 and negative from 1 to 3, right? And we know that 3 is a very special number. It is a critical point. Not a critical point, but it changed the sign. So in order to compute the integral of the function v of t from 1 to 4, let us separate them into the sum from the integral from 1 to 3 of absolute vt dt and integral from 3 to 4 of vt here dt, okay? So is it clear up to this point, and do you get why we break it into two parts here? Very good, thank you. So now we know that from 1 to 3, the function is negative. Therefore, we can get rid of the negative, of the absolute value sign, right? And it will be absolute value of vt will becomes negative of vt from this interval. And from the interval from 3 to 4, absolute value of vt is vt, right? So now we get rid of the absolute value sign. Everything is easy now. So we know that v of t is given as t squared minus t minus 6, right? Now we can replace it here, substitute it here. It will be integral from 1 to 3 of negative of t squared minus t minus 6 dt. And the second one is integral from 3 to 4 of t squared minus t minus 6 dt, right? But now everything is easy. Okay? What should we do?
Evaluate.
Yeah, evaluate the value. It's not very difficult. So before doing that, it's up to you. We can do it. We can get rid of the negative sign here anyway. Okay, you can do it this way. Negative, we need to compute the antiderivative of each of them, right? Let us get rid of the negative sign here to avoid mistake first. Okay. We don't like the negative sign because it causes mistake. Okay. Now, what is the antiderivative of negative t squared here? Negative of t to the what? Come on, help me please. Gary, can you help me?
Would it be it would be 3t cubed, not, I'm sorry, it would just be t cubed over 3.
Perfect, you did it well. See? And the negative sign, just write it here. It does not affect the derivative, right?
Mm-hmm.
The same story here. What is antiderivative of t here?
That would be cubed over 2.
T squared over 2, right?
Oh, I'm sorry, yes.
Yeah.
That's what I meant to say, I'm sorry.
You could, you could. And 6 here, give us?
It would just be 6t.
Very good. Right, the first integral we need to evaluate from 1 to 3, right? And the same story for the second integral here. We need to compute the antiderivative of t squared, which is t cubed over 3. The second term, remember, it has a negative sign, right? And negative 6t. And we need to evaluate from t is equal to 3 to t is equal to 4. Okay? Then now it becomes easier. Okay? So, anyone help me to evaluate the value of the first one? We substitute the value of the upper bound here, right? The upper limit. T is equal to 3 to t here. Therefore, it will be 3 cubed divided by 3 plus 3 squared divided by 2 plus 6 times 3, the whole thing's here, right? Minus the substitution of t is equal to 1 here, give us negative of 1 cubed divided by 3 plus 1 squared divided by 2 plus 6 times 1 here, right? That is the first integral. Then we continue with the second integral here, plus. So can anyone help me here? Rami? Rami, can you hear me? Okay, then Vikram?
Yeah, give me a second. I'm still writing it down.
Sure.
All right. So the first one I think is like 4 cubed over 3.
Very good.
Where am I? Plus 4 squared over, or minus 4 squared over 2.
Ooh.
Sorry.
Be careful here. There's a negative sign, right? So it would be negative 4 squared
Over 2
over 2 and
minus 6 times 4.
very good. So, and subtract the, now open the bracket, right?
Yeah.
The second one, it would be 3.
3 or negative 3 cubed over 3
3.
plus
Oh, be
3
careful.
squared. Yeah.
Because we have a parenthesis here, the bracket here. So we keep everything inside this the way it is. So 3 substitute here, right? We just replace the value of t by 3.
Yeah.
It would be negative 3 squared
Over 2
minus
Oh.
6
or minus 6 times 3.
3.
Sorry about that.
You could. Anyone could make a mistake here, because if we do not write the bracket here carefully, in front of this is a negative sign, and it causes mistake. If we forget the bracket here, then mistake would happen, and we don't want that happen. So then now you can go home and simplify this and use Weibo to find and get the result here. Double check it if it is correct, or if not, just let me know. Okay? Before ending this lecture, let me give you an example here so that you can go home and do it. Next time we'll discuss it quickly. Evaluate the value integral from 0 to 3 pi over 2 of absolute value of sine x dx. Okay? The same story happens. We need to get rid of the absolute value, the sign here, break it into the intervals where sign is positive or negative, then we'll be fine. Okay, do you have any question? I'm sorry for keeping you too long. So I think we are good, and you have a good weekend. Bye-bye, everyone.
See ya.
See ya. Have a good weekend.